And here is the list of sessions that we've done. You should be able to access all of these materials from the website, the tinyURL website. So first, if you remember, we began 2 weeks ago talking about machine learning foundations. And I do remind you that I have two versions of all of these notebooks. One is for the case where you have good internet and access to AI. Those are the basic notebooks. And the other I arranged for our particular conference so that those with poor internet could still use it locally. So the ones that are not amplified, I recommend you use Google Colab because you can take advantage of the AI. The ones that are called amplified, you can do using VS Code locally on your machine. Okay. So we introduced machine learning, some of the basic concepts, some of the basic techniques, how to set up a machine learning model. And then we went through an actual process from beginning to end of research question, setting up the data, setting up the model, evaluating the model, and giving results. That was sessions 3, 4, and 5. If you remember, the problem was the problem that the problem that we looked at was death before age 5. Okay, children's risk of death before age 5. So we went through the entire process there in sessions 3, 4, and 5. Right. In sessions 6 and 7, we went, beginning in session 6, we went back over this same problem, but at a higher level and introduced more sophisticated techniques. So you have these notebooks. I think at the end of my presentation today, I'll go back and do some of the exercises with you and see if I can get you started at being able to do this. But this is the outline of what we've done so far, introducing machine learning techniques, applying to one particular aspect, and then applying to that same problem again at a higher level. Now, in the course of presenting this model, the question came up, what about causality? What about causality? So we investigated the question, which children are at highest risk of dying before age 5? And we found some associated factors, education, wealth, location, and so on. But the question is, which of these factors are merely associated and which are causal? The importance of this question is, if the feature is causal, then we can take steps to change it. If the feature is just associated and we change the feature, that does not address the underlying cause. And I gave the example of symptoms of a disease. For example, if you have a fever, then you can certainly put cool water, you can apply, you can cool down the person. You are addressing the symptoms, but you're not addressing the cause of the disease. Right? If someone has a fever from malaria and you just make their fever feel better, they can still die from malaria because you're not addressing the cause. So there is this question of causality. And in fact, in sessions 12, 13, and 14, this question is addressed. Now, I'm not going to pick that up today. I'll pick that up tomorrow. Today I want to do something else, but I just wanted to say that for those of you who are interested in the question of causality, you can look at sessions 12, 13, and 14. Okay, and that addresses this question. It talks about directed acyclic graphs and finding the degree of influence. Two of the important terms here are directed acyclic graph and what's the other term here? An ATE, average treatment effect. Okay, so I do encourage you to read through these, and I will go over these again tomorrow. Right? So I just want to make you aware that that's available. Okay. So what I do want to focus on today is what I started to explain was this possible research project. And I envision that perhaps I can get some interested individuals from this conference we can form a team and we can work on this project. But first, I need to convince you that it is a project that's worthwhile working on. So the project I'm going to introduce to you is also in the materials that I shared. Let's go to our tinyurl.com. If you remember the address, tinyurl.com. It's in my laptop memory, so you can see it, acamda ML. So if you go there, and you go to research. So again, I think the outcome of this conference, of this workshop, really should be research. These are some different research research areas that have been suggested by this workshop. The proposal I'm going to talk about today is called advisory systems. Advisory systems. So you can go in there and you can see there are 3 PowerPoint presentations. Okay. So I'm going to start with the first one. I can download. You can download from here. You should be able to download also. I want to introduce to you the concept of advisory system, and that having AI at your disposal gives you the capability of developing an advisory system. So this first presentation talks about advisory systems in general. Here we are. So I'm going to introduce this. Okay. Here we are. Okay. 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 So advisory systems that learn. And it says why expertise needs a delivery mechanism. So what do we mean here? Usually when there is a need or there's a particular area that people need to know about, perhaps in health, perhaps in agriculture, where farmers need to know techniques that are effective for their crops, perhaps in manufacturing, when people need to know effective manufacturing processes, or they need to understand the status of their machines. So there's often cases where people need expert knowledge. Now it is great. Experts are few. So the challenge is to to help those who have the need match up with the expert. So for that, you need a delivery mechanism. You need a way of connecting the needy person with the expert who can supply the knowledge they need. And I'm going to use the example of agriculture. In fact, I'm going to take a particular application, which is cocoa farming, which is very important in the state. And cocoa farmers could possibly take advantage of expert knowledge, but it's not available to them because of location, because of communication, and so on. So that's the particular application I'm going on. That other applications might include health, people who need questions, and so on, or even people who want to learn how to use machine learning. Okay? So there are many possible applications. So expertise does not scale. That means with limited expertise, it's difficult to serve people. So one extension officer, one expert in culture, means of farms. One health worker may cover dozens of villages. Okay? One senior engineer supports plants on 3 continents. So the knowledge exists, but the expert cannot be everywhere. So most loss happens in the gap arrives. So you can imagine some diseased crop and is not. So this problem. So this is the problem. Okay. So what is an advisory system? photo of a diseased plant, a description, some kind of insect that they see on their plants. Okay. So the advisory system needs to be able to take. Then the advisory system should return a specific recommendation and also identify. You give just advice that has no motivation and no source. You want to give you want to provide a source for every claim, and you also need to tell the person when they should ask a human being. So the advisory system should know when to escalate cases to a higher level. Right? So the advisory system you could see from recommender systems. Recommender systems are already very common on the internet. For instance, a recommender system might tell you what movie you would prefer based on past choices of movies. I don't know if you have Netflix in Nigeria, but this is a service, and many kinds of recommender systems to get recommendations they might see. In fact, Google employs a system based on past searches. Google will give you results that are compatible searches. Now, advisory system is one step up from this. It's more targeted, it's more controlled, it's more detailed, and it's more justified. Right. So, all right. So when is it worth building? There are 5 conditions, and if there are 4 or more of these, because it will pay off. Okay, so the expertise is scarce relative to demand. For example, if the same question repeats across many users, so the systematic answers to questions, if the evidence is partially visual, if wrong answers are costly, so an expert is needed, and the aggregate of query valuable. This I think is one of the reasons of the advisory system as it functions. Gathering data. I mentioned earlier in using machine learning is the lack of data. Advisory systems can address this problem by doing 2 things that give answers to questions and collect data at the same time. Okay? So it's an active learning. It's what you might call it as it works, as it functions, it's learning. Okay, so it's both teaching and learning at the same time. All right. So I did mention one application, healthcare. So here's a possible flow of how it might work. Okay. Of course, the advisory system is not a doctor. It's not a nurse, but it can provide and in fact, I've used this myself using AI. So perhaps someone photograph a patient or a bump or something like this, or you describe this. Then this is sent to the advisory system. The advisory system will provide information. Well, this rash looks like it's fungus. And if it seems dangerous, it will tell you, doctor, this could potentially the advisory system, its own database based national treatment has a special database. It's better than just a blind Google search, and it also improves its data as it continues. Okay. So in application manufacturing, okay, so a technician photo failed bearing or a machine that's not working, okay, and it gets some causes and possible checks that it can make. Now, the already material there that gathered manuals and different databases. System does not have to be excellent at the very beginning. To set up what's called a corpus, which is an assemblage of materials, a database of materials that can be used for people who start using the system. But at the beginning, the performance will not be the best. As the queries accumulate, each option yields more data. As the data is brought in, the database improves, the suggestions improve. So it's a self-correcting, self-improving system. Really an application of a for peaks at launch and decay. An advisory system inverts this. Every query is an operator, and the compounding asset is the corpus, not the model. Okay, and is that once you get a procedure for developing an advisory in one systems in other areas, this really can be a big. It's breaking. It is the internet. I'm on Starlink. Yes. Yeah. Yes, I'm taking a. I'm taking a moment. They're trying. So is there a solution, or do I just continue? What? Okay, I think if you ask, see, because many people are using the same link. So if you ask them to mute their videos, improve the bandwidth. They'll tell everybody who's using some. All right. Well, I will try to continue slowly. Sorry about the technical limitations. Okay. So it's a self the core the database improves, and you can use this database for other. That's so it both provides opportunity research as certain people who can use this. You collect the library of images, so you can continuously add photos and improve your database. So if you do get answers that are validated, you can continue to use them. Okay, and the evaluation goes automatically. Now, of course, have an expert in can. So if you have an expert valid answer, then that answer can continue to be used in the system. So the data is a second product. Okay. Okay. So let me get some feedback here. I just got a notification the recording stopped. what's the status? Let me look at the chat and see. Okay. Okay, let's see. Sorry? Oh, okay. Right. Okay. Okay. All right. Good. All right. All right. So I got some feedback from the second room that I can continue. So here, the data is a second product, and this is really an exceptional advantage in Africa. You need the data to model effectively, and this, I think, is a good way to collect data. One name for this is called crowdsourcing. You don't go centrally to collect data. You distribute the data collection to the people who are using it. And this can be extremely effective. And it's no cost. It's no cost. The people who use your system are giving you the data in exchange for you providing them with recommendations. Okay. So every answer carries a place in time. So in fact, you can use the data as you're using it as a surveillance. For instance, if many people from a certain location report a certain disease, then you know that that disease is happening in that location, and you can send intervention there. So disease clusters, failure clusters, demand clusters, they can be detected simply because you are seeing what people are doing. It works in a similar way with Google Maps. Google Maps is a system for, well, maybe I can show you. Let's see if I can show you Google Maps. Okay. All right. So for instance, if I say I want to go from here to, if I want to go from here to Lagos. Okay, let's see that. Okay. All right. So you can see what it's showing me. Okay. Well, that's to Ekiti. I want to go to Lagos. Let's say I'm going to Unilag. Okay. Okay. Right. Now, see, it's showing me current construction zones, right? And I think if I go in more closely, it may even show me current traffic conditions. And the reason it can show me current traffic conditions is because it's collecting data from people now about the traffic conditions. Okay. People who are using the system are also providing data themselves about how fast they're going. Okay. Now, unfortunately, I don't see that there's any traffic data here, but sometimes when you run this system, you will see it shows red, yellow, depending on the traffic conditions at the particular time, at this particular time. So if I try lead now, maybe it will tell me. Okay. Right. So I don't see here, but this is an example of what could be called a simple advisory system. Okay. So the data is important. This is a way to provide your research group with quality data. Okay. Okay. All right. So you also, of course, need to be careful that these systems are constructed with integrity and they don't fail. Okay. I think that people who use AI have often had this experience that AI will make up citations. So this is something that must be avoided. Okay. And also, you must make sure that the data you have in your data file is labeled correctly, especially image data. If you have a wrongly labeled image, that's going to produce wrong answers. Okay. So as I hear that the data, if you use new data and the labels that you've assigned to it, you may continue the same errors, and the errors may become worse and worse. Okay. So you may have maybe overconfidence in answers that are not supported, and if there's no escalation path to a human, you always need a human to step in and correct errors like these when they happen. Okay. Okay, so now AI makes this possible. And you may think that this might involve a great deal of programming experience and expertise. You might think that you need to understand how to the ins and outs of how things work. But in fact, if you use AI, AI can help you step by step to construct this. Okay. Right. So, it should be something that can be built in weeks and not years. The important thing is to develop the initial database. And this does involve doing searches, doing some kind of simple data processing, some kind of simple screening of data. But that's the important thing. Once you get a corpus, once you get your initial database set up, then AI can do most of the rest. Okay. Right. So this is my first presentation. And then I want to show you uh, more specifically what I had in mind for a project that we could do. Okay, if I can find some interested participants and we can form a team, we can actually do a prototype advisory system. And the system I called it Ask Coco. I'm not sure if that's a good name. All of these things can be changed. Right, so let's take this. Right. All right, so let me, whoops, I think what I want to do is I want to show it. I want to show it in PowerPoint instead of Google Slides. So let's open it here. Okay. And we'll do from the beginning. Okay. All right. So I've been informed that cocoa farming is a major contribution to the economy here. And there are many factors that can cause problems like disease, storage, processing, and so on. All of these reduce the value of the cocoa crop. So any advice, any expert advice that can improve the cocoa value chain can really be transformative as far as improving the local economy. Okay, right. So the cocoa problem, cocoa is a major cash crop across Ekiti and southwest Nigeria. There's a disease called black pod disease. Black pod causes losses up to 90% in bad years. Okay. The expert coverage is very thin. Many farmers do not get good advice, or the advice is not timely. And there's also problems post-harvest, okay, during the cocoa processing. Okay. So there is a problem. Now, every problem is an opportunity. And especially if you have some technical knowledge, this technical knowledge may possibly lead to great improvements in this situation. So what I call Ask Coco would be an advisory system. Now, this does not exist. This is what I propose that we build. Okay, so what Ask Coco does, it sends a question and a photo. The farmer sends a question and a photo. The question and photo can have to do with plant health, soil and nutrition, or processing. Okay. Then Ask Coco will return a short assessment and plus what to rule out. Typically, especially at the beginning, Coco cannot tell you exactly what to do, but it can ask you some things to try. Okay. It can name treatments and cite and tell you what made the recommendation. And if it detects that you have an exceptional case or something that's very serious, it can tell you you really need to ask an official. Okay. Okay. So we do not have to train the model. The AI already is very good at this. AI can take a corpus and read the corpus and can take the data and extract information. For instance, if the AI has labeled images of cocoa disease, okay, so for instance, I can find on the internet, I can look for cocoa black pod disease images. All right. So once you build your corpus will include images like this. And the corpus can take an image from the farmer, compare that image with these images, and classify. There are already very powerful image classification AIs out there. So we want to make use of the classification algorithms that are already there. In US, we say, don't reinvent the wheel. Don't create a system that already exists. Okay. Okay, so you have classifiers trained on lab images. So if you do make a new classifier, then these classifiers are difficult to make and they don't perform typically very well. Okay, there are no citations. There's only a fixed set of labels. So instead of training, we're retrieving. Okay, we're retrieving and then we're comparing these photos with existing sources. Okay, so you have your vision model, you have your curated data, you have channels where you can retrieve the information, and then you have a safety mechanism that's put in place. Okay, all right. So the citations are the product. What you provide are the citations, are the sources, and the recommendations that the sources give. So this must be done. This must be done carefully. But there are tools out there to make sure that this happens. Okay. Okay. So the safety comes in the way you design the advisory system. So you can specify to the AI that all sources are verifiable, all recommendations come from a table, a given table, and the code only takes what's in the verified database. Okay, so I propose a team of 5 people for 5 days to put this together, and I have a schedule in my next set of slides, and I think this is possible. If this is something that we could do during the next week, put this together. And as I said, once you have one of these advisory systems in place, once you develop one, then you can develop many. You then have the tools to develop advisory systems in all of these different areas. Okay. So we would set a criterion for what success is, and I think this is very ambitious. It might take more than 1 week, but I would like to see if I can get together a team that is willing to do this. Okay, let me go back and one more slide here. So here is the proposed schedule. I'm not going to go through this one in detail, but just so you can see that I have worked out a proposed schedule for making this happen. Okay, so I'm just going to flip through this. There are various things you need to do. I think that a lot of these terms you may not be familiar with. We certainly need to use AI to help us every step by step. But this does map out the entire project in terms of milestones that will show how you are progressing in the project. Okay, so I think I've presented a great deal, but the summary of what I want to present today is this idea that we can develop advisory systems. These advisory systems meet a real need. These advisory systems can be extended to multiple areas. We can do this with available AI, and that this will in fact improve the research that we can do because it develops more data for us to use. So I think I should definitely stop here and see if I have any questions. I suspect that it will take some time to understand everything I said, but maybe I can take a few initial questions.
Right.
So thank you very much. I can stop sharing.
Yeah, thank you very much, Professor Tron, for that wonderful presentation. And if we watch, actually, Professor Tron has taken us through, of course, the legend background from what we did last week, talking about causality and as well as association, and then bringing it up to the point of where we need data, especially for us in Nigeria, for us in Africa, how data has been a major constraint in terms of doing machine learning models. And then he now went on to talk about the advisory systems. Of course, he gave us some certain examples of an advisory system, which is the Google Map, and how that collects data in real time to give feedbacks. And then Professor Tron went ahead to now begin to also make requests for interested participants to actually join in the Ask Coco project. Maybe we may ask Professor Tron how, maybe the first question would be how he came up with the name Ask Coco for that particular project. Professor Tron, I don't know if you can throw a light to us.
Well, I asked AI.
Oh wow,
So,
that is
yeah.
beautiful. Yeah, great. So that is beautiful. So of course, we'll be taking questions. And I don't know how many of us have questions for Professor Tron from the area of that he has presented briefly before he takes up the next stage on particularly advisory systems, which he has presented on advisory system. If we have question, you can indicate. I don't think you can just indicate. You can just give the emoji by raising up your hand, and we'll take questions. And I don't know, can I get a confirmation? Is there any question already dropped on the chat box? I don't think so.
Yes, one question.
Okay, just raise your hand up and then we'll give you the opportunity to ask the question. If you have...
I mean, there's a question in the chat.
In the chat box, okay.
Yes.
Okay, a quick question. Okay, maybe you can drop your question in the chat box and I will read it out to Professor Tron. And I think the first question I have, a quick question. Does one have to be knowledgeable about cocoa to be part of this team? Yeah, a question for you, Prof.
No, that's the point. The point is to find expert knowledge and not to be experts ourselves, right? The point is to assemble a database from experts and not to be experts ourselves. I mean, there is a Cocoa Institute. There's a database called Plant Village that has pictures of diseased plants. So our task is not to be experts ourselves, but to bring together the data that can be used as a basis for the model.
All right, great. I think that answers that question. We do not need to be experts ourselves. Of course, like Professor Tron has talked about, you do not need to recycle things. Things are already there. The images are already built in. So all we need to do is to prompt our AI, and then of course it will give us those images, and we'll be able to relate it with what is happening currently in those sites, and then give the farmers or the cocoa planters feedback in real time. So thank you very much. Another question here for Prof. Okay, this question says, what's the criteria for picking the selected 5 for the project?
Okay, all right, so that's something that I need to come up with. I will need to make a Google form that interested people can respond to. But for now, I think for preliminary, why don't I just share with you my email, and you can email me your interest. In your email, you can just, whoops. It's not letting me send it. Oh, okay. So I guess, sorry. Okay. All right. Okay. Sorry, I need to, yes, so let's see if I can do this. So there's my email. You can send me an email, please. I can collect the emails and then we can tell. So also you can tell me your current location. Okay. If people are located here, it makes it easier, and we can actually have physical meetings. We can possibly have people who are online, but people who are here, we can have physical meetings and develop the project.
Okay, great. And actually, I think Prof has used that to actually respond to the next question, which asks, does the project involve the physical presence of people working on the project or in areas where cocoa is produced? Let me take that again. Sorry, Prof. Does the project involve the physical presence of people working on the project in areas where cocoa is produced?
No. We're not going and collecting data. We're not going out to the field. We are making use of our task is to make use of resources that are already there. So no. I think what's most important is a good connection, good internet connection, because certainly we would have to rely heavily on AI in this project. So the major tool is not us going out and collecting data in the field. The major tool is us using AI to get data from the internet.
Oh, great. Thank you very much, Prof. And of course, as Prof has also earlier explained that the advisory system can actually work for various sectors and for various fields. And of course, this initial stage is a learning process for us participants, which eventually we can take a key from into applying in other areas of our expertise. And that leads us to the next question, Prof. The next person is asking, how can the advisory system be applied to One Health sector?
Okay. Well, to apply to the health sector, we would have to go through the same process using health data. You design an advisory system specifically for an area. So I'm proposing to start with a cocoa farming advisory system, and the knowledge we get from designing this system could be used to design a system for health data. But of course, we would have to start all over again. We would have to do the same process, but different data. We're not going to use the COCO system to make recommendations for health.
Please, let's try to mute. Let's try to mute.
And I think I see a question here about prior knowledge of cocoa production, and the answer is no. I don't know anything about cocoa production. The point is that we need to connect the expertise that's there with the people who need it. So we're just making connections. We're not the experts. We're just making connections.
Yeah, thank you very much, Prof. So that question has been responded to as Prof has rightly reiterated, that you don't need to be a professional in that field, that we are the connectors, that is in terms of developing the advisory system when it comes to cocoa advisory system. So you don't need to be afraid. You can, of course, indicate your interest and also your availability to Prof. Thank you very much. And so I think Prof will continue. Is someone raised it?
Okay. My hand raised up.
Okay.
I don't know if I can talk.
Please go ahead. Please go ahead.
Yeah. So, Prof, thank you for this insight. I know with WHO there's this idea about using non-clinical data to forecast outbreak. And this intent is to make sure that we can quickly detect outbreak before the clinics or health facility are overwhelmed with cases. For example, in the cases of Ebola and the rest. And most of the data source,
Go on, we can
Hello.
hear you. If you can.
Okay. The light went off, so I thought I was cut off from internet. Sorry. Yes. So, the data source most of the time will be like maybe if there's increase in pharmaceutical sales, animal health reports, environmental metrics. Maybe people have started searching online for symptoms of Ebola and stuff like that. So, guarding all these metrics, is it something else too that can fit into this advisory system that you are talking about for cocoa?
Yeah, I think that those are all somewhat similar. The
Oh,
distinctive advisory system is that you're giving people a motivation to send their own data. Right. If people need a reason to send in data, and if we have an advisory system, then people can expect some valuable information when they send it in, right? If you're just doing pharmacy records, this and that, if you're asking institutions, they get no benefit. They get no direct benefit from sending in, right? You're asking them. You have to ask them, please send me because I need it. But with an advisory system, you don't need to say, please send me. They want to send it themselves. You see what I'm saying? So that it's a different, it's a much more motivated system. It's more crowd-based. It's more people-based. It's not institution-based. As I said, people with the other systems that you mentioned, people have no reason to send in their data. But with an advisory system, people have a reason to send in their data.
I think that's clear enough. Thanks, sir.
Okay.
Yeah, thank you very much. So I don't know if we have another question. How do I reach? I think that has been answered already. You can reach out to Prof via his email at tron@timeuct.edu. So you can reach out to Prof on that. So I
I have a
think,
question. Can you hear me? Sorry.
okay, Victor, please go ahead with your question.
Sorry. Hello, can you hear me? Can you hear me?
Yes.
Yes, we can hear you, Victor. Go ahead with your question.
All right. Okay, thank you. Thank you, Professor Tron. So I think we had a similar discussion earlier. So I wanted to ask about because you said that once you have a usable product in this line, and you intend to also like scale across other, say, crops or whatever area. So my question is that, I mean, I mean, the vision at the moment, is it to scale the same model across different data sets, or it's going to be streamlined? So the already trained data on cocoa would just maintain the training around cocoa, and you have a separate model around different field? Or is it going to be a single model that would be able to first classify the type of crop and then eventually streamline into the particular crop itself? Or you just scale it, say, horizontally? Okay, a separate model for each crop, separate model for each whatever area you want to apply. So I'm trying to understand the vision behind when you said you intend to probably scale across different areas or different crops. That's my
Yeah.
question.
Thanks for the question. I never use the word scale. I never use the
Okay,
word
okay.
scale. I only said I said apply the same procedure. So I don't see expanding this model to cover other crops or other subjects. I do not see any scaling. I think that it's better to have this model become very good at
Okay.
what it's
So
designed to
for a
do.
different crop, if you have,
But just to answer your point though,
okay.
once you do this for one field, once you go through this process for one field, you do the same for something else. So with reference to your question, you would develop an entirely different model for health, an entirely different model for manufacturing. Okay. But the process of creating these models is the same, right? By doing one model, you learn the problems, you learn the techniques, you learn how to do things effectively. And then you can do the same thing with completely different data. So there's no scaling. There's reproducing, there's not scaling. So thanks for asking that question, because because that is a very important point.
Yeah, thank you very much, Prof. For that response. So I think we do not. Okay, all right. So yes, on that question here, you have the skills or knowledge on how to do others. Okay. I don't know how this, but maybe I will try to rephrase
No,
or
that's not a
paraphrase this.
question. I'm just
It's not a
collaborating what
question.
Prof said. That if you know how to do one, then you can apply the skill or knowledge to others.
Yes,
All right.
that's the point. That's
All
the
right.
point. Yes, thank you.
All
Yes.
right. Okay. Okay. Great. Great. So like I say, if you learn one, you can then apply what you've learned into other sectors, and I think that is what we should take home. And also, once we are building on this team, we should be rest assured that the skills we are going to learn with this COCO project or Ask COCO actually enable us to also apply it as it's into our own respective field. All right, thank you very much. So on this note, I will ask my Prof to continue the next session of his talk.
Okay. All right. Sure. So this is really what I wanted to show for this new project. Apart from that, I think that from my seeing people using the notebooks, I still see that people have some trouble working with them. So I wanted to go back, and this next part I think it's more designed for the people who are new and who are having trouble just getting started. I thought I would do some of the exercises in the notebooks, so you can just see how they're done and learn from that. So I think I can start way back in Notebook 3. All right. And I can do the process from the beginning. Okay. So if I do Notebook 3, of course, I would need to get Notebook 3, and I would need the data. So I'm going to pull my Notebook 3 and my data. Let me get my VS Code going. So I'll start a new window. And I think what I should do is I'll just create a new folder and put my Notebook 3 and the necessary data in the same folder. So why don't I go ahead and do that? Let's see if I can find my Notebook 3. I should find where it is. Should be somewhere here, and I think I have it here and here. And I'll go to my Notebook 3 here. So I'm going to do session 3 amplified. Let me just go ahead and get that here. Session 3 amplified. And I think I can, while I'm here, I'm going to get session 4 amplified also, and session 5 amplified. And we can work through this. Let's see if I can find session 5 amplified. Where's my session 5 amplified? I don't actually see it here. No, it's I only have the Sol version there. Okay, so let me copy this, and I'll just create a new folder on my desktop. Let's see where my desktop is. That's the wrong desktop. So I'll go to this, I'll go to my C drive and do this. I have too many folders. All right, we'll just go here. And then I'll go to my desktop here. Okay. And where's my desktop? Okay. Oh, I'll just put it in documents, that's fine. Okay. Let's see. So I'll create a new folder. And then I'll just say Camda, and then notebooks. Okay. And I'll put my notebooks here. And I will need the data. So let me go back and find the data. Should be, I'll just go back. Okay, should be here. I think it's in the public as well. Let's see where it is. It's here. Okay. Wrong answer. Okay. Nigeria DHS. Yes, it's here. I could download it again, but I think that would take some time. So here it is right here. It's that .sav file. Let me make sure it's all there. Yeah, it's right there. So I'm going to copy this. And I'll go back to where I want to go. Let's see if I can go back. Whoops, that's not where I want to go. Let me go here and go here. And I want to go to where I was. Okay, it's going to be here under users. Okay, and here. And I want to go to my documents. And I'm going to put in my Camden notebooks. And I put it right here. Okay. All right. So the point is I have my notebooks and my data in one place. Okay. And then I'll go ahead and do the tutorial. So let's see. So one way to do this is just to open my VS Code. Just type VS and it should come up. And then I should open that folder. Okay. So I need to go back and find that folder again, documents folder, right here. And go to Camden Notebooks. And I think Camden Notebooks should be fine. And here you can see the notebooks and my data there. Okay. All right. So I'm going to go to session 3 amplified. Okay. And let me close this here. Okay. All right. Now I'm hoping that I have all of my, I'm pretty sure I have all my packages installed. Okay. Okay. Here it says detecting kernel, so it may take a moment to find them. I think if I type, I think it's Shift P. Is it Shift P or is it Control Shift P? There we go. So I do Control Shift P and I look for my Python. And then select interpreter. Okay. I'm not sure why it's not coming up. It should come up here, Python. That's strange. Let me see if this is happening, if anything's happening here. Okay, all right, here we go. Python environments. We can do this. Okay. Well, it looks like the, okay. Okay, it looks like it's in, all right. So I think there's a problem here. It's not finding my Python. It's not finding my Python. So I'm going to stop this because I don't think this is going to be very good. I don't want it to use all the bandwidth. Let me see if I have this in a different notebook here. Okay. Well, it looks like I have these here already. So I'm going to go ahead and do it here. Okay. So I'm going to go to this folder instead. So let's go to VS Code here, and I'll open this other folder. Here, Cam.ml. I think I should just do a Cam.ml, it will be fine. Okay, yes, so now it just says select kernel. That's fine. I don't know why there was a problem with my other one, but this one should be fine. This is very strange. I'm not sure why I'm not sure why it's doing this. Maybe it's because it's restricted mode. Okay. Okay, I think it was because I was in restricted mode. So here, if I can now do this. Okay, all right. So let's go ahead and make sure everything is installed. Okay, so we've been through this before. Here it says, click into an empty cell or add one, hover before the last cell and click plus code. Type this and run it with Shift Enter. Okay. So if I click here, and then I do plus code like this. Okay. And then I can go ahead and copy those lines. Okay. I think the best way to copy these lines is click twice, go in, click twice, go in, copy, and then I can go down to my new cell, right click, paste, and then go ahead and run. Let's see. Okay. And that's basically the procedure for doing most of these exercises. Okay. Of course, these things take time. Okay, so that's good news. Okay, so I think so I'm done with the first cell. Okay, all right. So remember this. We've been over this before, so I don't need to talk too much in detail about this. Set up the data, frame the research question, understand the variables, explore the data, build the modeling data set, and so on. Okay, right. So we want to turn this into a well-defined machine learning problem. So whenever you run a notebook, you do need to run the cells one by one. So I'll go ahead and run this one. Okay, and this says this is all fine. Okay. We've talked about this save figures before. By the way, I don't need this. I don't need the files anymore, so I'm going to make that big. Okay. Now I do want to save figures in the notebook, so I'm going to turn this into true. Okay. And we'll just go ahead with that. Okay. Okay. All right. So it says the notebook reads a real DHS birth recode file from your local disk. There's no Google Drive to mount in VS Code. The file needs to be somewhere your Python can see it. You only need the single file, okay, not the whole Nigeria data set. That's fine. It says put this in the same folder as this notebook. So let's see. And I do have it the same folder as the notebook. You can see in my file list. Okay. All right. All right. So there are many tips here and additional instructions, but we don't need to follow this because we do have this file in the same notebook. Right. Okay. So this should be able to run just as it is. Okay. So let's try. All right, it's running. And I think it's finished already. Okay. Now it looks like it's finished. Okay, loaded the file, loaded all the records, and all of this. Okay. Okay, so frame the research question. Which children are high risk of age before age 5 using information available or shortly after birth. Okay, now this is our population. These are our input features. This is our classification task. We're going to use the AUC. Okay, and we're not estimating causality. Okay, why this data set? We've talked about this before. Okay, so here we have the names of the variables. We did recoding so that these variable names became labels. Okay, you did this exercise with century month codes. Okay. DHS data stores data as calendar dates since January 1900. Okay, and here is the formula. Okay, so exercise 2.1, compute a CMC by hand. So first of all, add a code cell below. I used the formula from the markdown cell above, compute the CMC for January 2020, and store it in a variable. All right, let's just read these one by one and we'll go through. First, it says add a code cell below. Well, there's one right here already, so I'm fine with that. Then it says using the formula from the markdown cell above, compute the CMC for January 2020. Okay, so it says use the formula from the markdown cell above. Okay, that's the formula. That's the formula up here. But it's the same formula here. Okay, so I can copy the formula from here, starting here. There's my formula. Okay, and it says use this formula, compute the CMC for January 2020, and store it in a variable CMC January 2020. All right, so I'm going to take this variable name, copy it. I do Control C for copy. I paste it here. Okay. Okay. Right now, if I run this now, it's going to tell me name error. Told it what year it is. So here they told me the year is 2020. So let me put here year equals 2020. Now I need to put this before the place where year is used. I can't put it afterwards. I need to put it before. Now the AI made this suggestion. That's because I'm on AI. In fact, this is the correct suggestion. Month equals 1. Okay, because I do want January 2020. So to accept this suggestion, I can press tab. Okay. Right. So now I have the year. Now I have the month. If I run this, nothing happens. Okay. Right. Okay. Now, what's the problem? Because nothing happens, let me read the instructions. So it says, use the formula from the markdown cell above, compute the CMC from January 2020, and store it in the variable CMC January 2020. Then it says print it. So I didn't do that. So I need to print it. And so I CMC for me again, which I can accept. And then I run, and then it gives me 1441. Okay. All right, so then it says now compute the CMC for the month and year you are born and print it too. Now, a good way to do these things is to use code that you already know works, copy it, and modify it. So here it says use the CMC for the month and year you were born and print it too. Okay, so this is not the month and year I was born. So I can take this, I can copy, Control C for copy, and then Control V for paste. And my year of birth, you can do that. And then my month. And then here's, I shouldn't call it January 2020. I should call it CMC birth. Okay, right. Because this is the year of my birth. Okay. Okay. And then here I can do print CMC birth. Okay. All right, the AI made this suggestion to put birth in here. So I'm going to put tab and accept it. And then we go. Okay. All right, so you can see I have a different CMC. Okay. Right. And then here it says, what's the next one? Okay, so using your birth CMC and CMC January 2020, compute how many months apart they are. Just subtract. Okay, so I need to subtract these two. Okay. And this is how many months apart. Okay. Okay, so I can call the variable months apart. Okay, equals. So I'm going to do CMC January 2020. All right, so here the AI suggested, again, for me to do this. I think I want to turn off the AI suggestions because it's more, I think I want to do this by myself. Okay. Okay. So let me ask, in fact, I don't know how to turn it off. Okay, so let me see if I can ask how to turn it off. I'm going to ask here, I'm going to ask my AI how to turn it off. I think it's this one here. No, it's not that. Is it here? So I'm just going to ask my AI here. Okay. 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 Yes. This one here. I want to turn off. Okay. Yes. This one here. Okay. Okay. So it says press Control Shift P, run toggle suggestion. Okay. Okay. So let me do that. So I go here and I press Control Shift P, and then I say toggle suggestion. Okay. Okay. Let's see. I think this one here. So I think that will turn it off. We'll see. Because I don't want the suggestions anymore. Okay. So let's see. So we have here. So I'll call this months apart equals. Oh, it's still there. Maybe I can do it here. Okay. Let's see. I thought it would turn it off. Let's try this again. Okay. Okay. Let's see. Okay. Let's see. So we go here. Let's just go here. It says set editor. Let's open settings. Oh, here, settings, here. And then what I want to do. Okay, yes. Okay. Okay, suppress suggestions. I think that should do it. Okay. All right, let's see if that works. Okay. So this would be CMC. Look, it looks like it's not going to work. So I just have to take it as it is. Okay. And then here I do want to say this. Okay. Sorry. Am I not sharing my screen?
You are sharing your screen. Maybe you need to restart for that to work.
Okay. All right, let's try that. Yeah. Okay. Let's see. All right. It's quite annoying to have these suggestions. But if I do this, then I would want to print. All right. So here again, it's asking me to do this, print months apart. That's the correct suggestion. That is what I want to do. So let's go ahead. So it is printing months apart. Now, probably you should say something like this. You should add some words to illustrate what these are. And this is going to be, I can call this January 2020. And then that will tell me that this is for January 2020. And then this is for birth. And then if I can print months apart. And then months apart like that. And then you can see the words will be there. Oh, here I should say print birth, like this, and just do that. Okay. Right. It's better if I spell birth correctly. All right. So then here it says explore the data. Now, again, if I want to explore the data, I should run all the cells one by one. I should not skip any cells. So go ahead and do that. So you can see this, you can see the variables and the types. Okay. All right, here it says, check missingness of a different variable. Okay. Now, here it says, if you see here, birth interval, it did check missingness for birth interval. So it checked missing values for these different variables. So let's see if we can do that for another variable. So here's what it tells me to do. Scroll up to the cell above, copy the line that builds miss. Okay. But let's go ahead and do these one by one. Scroll up to the cell above, copy the line that builds miss. Scroll up above, copy the line that says builds miss. It's right here. So I'll copy that line. Now, one way to copy is you click at the beginning, hold down the shift button, and then press the down arrow. And that will copy the entire line. Right? That's very convenient. So just tell you again, if I want to copy this entire line, just click in front of miss, hold down the shift button, and then press the down arrow. Copy. Okay. So I did Control C for copy. Okay. All right. So it says paste it below and change the column list to birth order, total children, HH size, and zone. Okay. So it says paste. Below. I'll paste it here. Control V for paste. The column list to birth order, total children, HH size, and zone. So the easiest way to do that is come here. This. Control C for copy. All right, now notice that here, what happens? I'm not sure what happened. Okay, this I clicked this by mistake. Okay. All right, so it says I should change the birth order list. Now you notice that there are two brackets here. There's the bracket here that indicates it's from the data frame, and then there's the bracket here that's the list. So I want to replace this list with a new list. So I'll just take this out. All right. So here I have MIP to do next. Okay. Okay. And then says print the result. So after that, I should do print miss. Right. So let's see what this says. Okay. And you can see that there are no missing birth order. All right, now here, this step was data exploration. Different aspects of your data, the distribution, the histograms, and so on. So let's run this and see what we have. Okay. So this one tells me out of all of my data, 69,000 survived, 7,800 died. Okay. And then there's under 5 mortality rate by zone. We've talked about this before. This is just the per number in each region. Okay. And then here by education, the different rates, by wealth quintile, and by middle and by urban. Okay. Okay. Now here it says I should add another subgroup, sex of the child. Okay. The loop above cycles through a list of tuples, one tuple per subgroup variable, column name, printed label, value mapping. Okay. Okay. So here it says scroll up to the cell above, add one more tuple to the list. Okay. Female, sex of child, 0, 1, 1 female. So first of all, let's look and see where the list of tuples is. So it seems like what we have here, so it looks like what we have, I have a couple of these. I've got this one here, zone, geopolitical, none, education, maternal education, and then this list, and then wealth quintile, and then this list of categories, and then urban, rural, and then this list. Okay, so you can see the structure here. This one's talking about zone, and zone was printed out here. The second one was talking about education, and education was printed out here. Was talking about wealth quintile, and wealth quintile was printed out here, and then finally urban and rural. Okay, right. So in this exercise, they're asking me to add one. I want to add another tuple. And here's the tuple that it wants me to add. Female, sex of child, 0 male, 1 female. So I'm going to go in here. I click twice to get into the markdown cell. I select this tuple here. And I'm going to copy, Control C, to copy this. And then I'm going to paste it up to this cell here. Now, where do I paste it? Well, I should paste it after these other ones, right? This was my first tuple. Zone, this is for zone. This one was for education. This one was for wealth. This one was for urban and rural. Okay, and then let me paste one for the sex. So it should go right here. Okay. Okay. So female, sex of child, and then male, 1 female. Okay. All right. So let's see if this can help. Let's see if this works as I pasted it. See if it runs. Okay. And see if it did in fact add the female outcome. All right, it's right here. Female 9.6, male 10.7. Okay. So this is the death rate for females, death rate for males overall. Okay. It's not the proportion of females and proportion of males, it's the death rate. Okay. Instead of female, I think it would have been better to put sex here because that's really what we're talking about. I'm going to put sex instead because this is the death rate by sex. Okay. And where did it go? Looks like there was a mistake. Oh, I see. Because female is the name of the key. So I do need to keep it as female. So let me go ahead and say that. Okay. So I do have to keep it like that. That was the name of the variable. Okay, so I now have the mortality rate, sex of child. To make this print again the way it's formatted, I just do this. Right. Building the model data set. I don't know how much more time I have. I'm just going. When am I supposed to finish? Just tell me when I'm supposed to finish. It looks like maybe I go 2 hours. I'm not sure. Yeah. Go to until 12:30.
Yeah.
I'm past. Okay. Okay. So I have another 2 minutes. Yeah. Okay. Yeah. Okay. Because it's almost. I think if I go because I started about 10:30. Why is it? Yeah. 10:45. Okay. So I go another 20 minutes. Yeah. 12:45. That's fine. Okay. Good. All right. So let's keep going. Okay. All right. So we assemble the feature list. Okay. Okay. All right. Okay. Okay. So we've talked about missing data. I think I need to execute this. Make sure that you run every cell as you go along. So I need to execute this. Okay. So we have so here it gives us a summary. It gives us the count of each feature and the mean, standard deviation, minimum, and these are the quantiles, okay, the quartiles, and then this is the maximum value. Okay. And you can see that these all have 77.3. This is the total data set size. This one has fewer because it assigned NA to the value to those who were born first. Okay. All right, so you can see that there's a minimum value, there's a mean value. I think this must be in months. This is the mean birth interval in months, and then this is the maximum birth interval. Okay, and then first birth. Here it's saying this is the mean and max and so on. Okay. All right. Let's see. And the maternal age, you can see the mean here and the maximums here. The mean here, in fact, first birth is either 0 or 1. The mean of 0.27 just means that 27% were the first births. And so, okay, so this is fine. So birth order, that on average, the child was the third born. But so it looks like the maximum was 14 children. So that's quite a few children. So let's see. So we also have multiple birth. You can see that there are very few multiple births. The mean is 0.03. That means only 3% of the births were multiple births. These are the other ones: female, urban, education, wealth, household size. Every one of these columns is just showing you the characteristics for that feature. So it's good to look at the data to make sure it looks reasonable. It looks like there's a little bit more data here. It says, let's see if I can scroll down and see. Does it scroll down? Because it doesn't show everything. It doesn't show the first part here. I suppose I can do that, and then it shows everything. So total children 17 is the largest number of total children. Okay. All right. So here it says birth interval is NAN for first birth. This is structural missingness. It's because of the way the variable is defined. So let's go ahead and do the exercise. Let's check that birth interval is missing exactly for first births and nothing else. Okay. We can check that claim with code instead of just taking it on faith. In other words, a birth interval should be NAN exactly for the same instance, the same rows where the first birth variable is 1. Right? First birth indicates that it's the first of births. All right, so let's go ahead and do code that shows this. So here it says add a code cell below. That's already done for me. And then here it says write this command here. So what is this doing? This looks like a complicated statement. Let's try to analyze what it's saying. Here it says a DF model lock. DF model is my data set. Okay. Lock just means location. It means I'm searching within this data set. Okay. And what I'm doing is I'm searching for the rows where DF model is NAN. And when first birth is going to be 1, okay, and I'm going to take the mean. So it says the birth interval is missing exactly when first birth is 1. Okay, so I believe I should get 0. So I should let, I'll call this result. And I'll print the result. Okay, so I should get 0 because none of the variables that none of the variables that are NaN are not first births. Okay. Oh, I'm sorry. It says 1. This means because all of what this is saying is that all of the instances that have birth interval NaN also have first birth equal to 1. So so that's showing me that in fact all of the variables that have first birth equal to 1 are also NaNs in the birth interval. All right, so here we say encode and split. All right, so this time we're going to use we're going to be tuning hyperparameters. So we want a training set, validation set, and test set. So first we split into test and training, then we split the training into training and validation. Because we do want to tune hyperparameters for these different algorithms. Right. So here we have we're setting up our data. We're identifying the different types of variables. And then here we have our DF model is our features, and then Y is the target. Okay. So features is the set of all features. Okay. Okay. And you can see that features was defined with all of these variables. Okay. So first we split into train and test. And here we have a relatively small test size. That's because we have a lot of data. So we can make a test size that's a little bit smaller and try to get more accuracy with a larger training set. And then we split the training set in addition the same way with 15% for validation and 85% for the actual training. Okay. So let me go ahead and run. Taking a little while. Okay, and let's see if it worked. Okay. All right, so training was this much. Validation and testing were the same size because we took 15% for each. So we don't use the test set until the next notebook. Okay. All right, now here it says change the random seed for the test split. Okay. So here we used a random seed to split. Now here we always had 10.2% mortality. Remember, this is because we did stratify. Okay. Okay. So let's go ahead and change this with a different random seed. Here we used 42 for each one. Okay. We can actually use a different seed for both of them. You don't need the same seed for both of these. So I could say I can make this 31 and I can make this 22. It really doesn't matter. And let's see what happens with these splits. Let's see if is it done? Let's see. Okay, it's still 10.2%. You don't see any difference at all. Okay. So, and this is what Stratify does. Now, if I do, if I say that, if I say Stratify equals n here, we might get something different. Let's see if this changes things. Whoops. Whoops. I'm surprised that it's not saying. Oh, I see. So this is, okay. So let me ask AI here. Okay. Well, all right. So, all right. Well, let me just go on. All right. So you can see that because it's stratified, that we're still getting the same proportions. So I changed it back. I think we're fine. So even if I change the random seed, it's not going to change the split. All right. So we do have class imbalance. The number that die is only 10%. So we do want to account for this. So when we do our training, we do want class weight equals balanced. Okay. We can use class weight equals balanced or SMODE. I think that was discussed in one of the training sessions. Okay. Or you could just do threshold adjustment. That would also be fine. Okay, but we're going to use class equals balanced here. Let's go ahead and run. So here we have our precision recall F1 score. Okay. All right, so you can see here that the naive classifier, I think this one was this. I think this one is without training balanced. You see, this is and you can see that the overall accuracy is good, but it's doing very poorly on the most important class. Now, if we have class balanced, you can see it's quite a bit different. Here, the precision is better, but the recall is somewhat worse. Okay. The precision is actually even better than this one. Now, here the precision is 0.169. What that means is that a number of children who did not die are identified as having died. Okay, so in fact, only 17% of the children identified at risk of dying, in fact, died. Okay. But on the other hand, 66% of the children who ended up dying were identified as being at risk. Okay. So you see the F1 score here is much better than this case. Okay. And then the accuracy, this is the overall accuracy. Then this is the macro accuracy is just averaging these two. My time is doing. Okay. Now I think in the cell above, duplicate and change class weight equals balanced to class weight equals 0, 1, 1 through 5. Okay. This tells the model to treat every died example as if it were 5 copies. Okay. Right. So 0 and 1, these are the class labels. 0 means not died, 1 means died. So these are the weights that I attach a weight of 1 to not died. I attach a weight of 5 to died. So let's go ahead and do that. Go to the LR balance line, copy it, and change it to LR manual. So where's LR balance line? It's right here. All right, so I'm going to do the same thing. Shift down arrow will copy this. So Control C for copy. Put the line here. Okay. All right. Now, instead of class weight equals balanced, it's telling me I should change it to class weight equals 0, 1, 1, 5. So I'm going to go here and change this. Okay, I need to put it inside curly brackets. 0, 1. Whoops, comma, 1, 5. All right. And then I want to call this LR, let's see, let's call it LR manual. Okay. 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 Then it says below the existing fit call, add LR manual fit. Okay. Okay. So let's see. So let's see if I want to do this. So where are the fit calls? All right. So let me copy this. So I'm just going to fit this one. And then add one more classification report block. Okay. To print LR manuals report on the validation set. Okay. Okay. Let's see. Okay. So let's see. Let's go to classification report. Okay. Okay. So I'm going to copy one of these here. Okay. This is classification report for class balance. I'm going to do it now for this new one. So I copy that. I put it down here. And this is not class balanced. This is going to be manual balanced. Okay, and then this is going to, instead of LR balanced, it's going to be LR manual. Okay. And so this should be fine. This should give me the same thing that I did for balanced, but only in this case, we chose the class weights by ourselves. Okay. So let's see what we get here. Okay. All right. So here we can see here that we have precision and recall. Now you can compare this one here with the class balance classifier. To make this easier, I think I'm just going to take this and duplicate it down below so that I can print them both together. So I'm going to copy these lines, copy, and go down here. Okay. And we'll just print it again so we can compare them directly. All right, so here's manual balanced, here's class balanced. So take a moment, see if you can notice a difference. So which one had higher precision on the died children? Okay, and what about the recall? So you can see here that in this case, the precision here was lower than this one, but the recall was quite a bit higher. Precision was lower, recall was higher. And the reason is that the class balancing was I can say heavier on the died children. So when we did class balanced, it counted more the correct classification of children who died as compared to children who survived. So in other words, a missed dead child was more costly in this case than in this case. Since it was more costly, the recall here is higher than the recall here. But you pay a price for higher recall with the children who die. And the price you pay is the precision is less. That's the most important cost. Now, the precision and recall for survived apparently does better here than here, which is a good result also. Okay, I think I have taken my time. It's 12:43, and I do encourage you to go ahead and do the same sort of exercises in the other notebooks. Go through and try to make the changes yourself, because you do learn by doing that. So you can do session 4, session 5 the same way. Okay. So tomorrow I can go ahead and introduce notebook 12. Okay, but I think I'm finished. And we'll see you tomorrow.
All right. Thank you very much, Professor Tron, for that wonderful session again. And if you would agree with me, it has been the same energy which we had on site through the last 2 weeks, the same energy that we can see that is also being delivered here, even online. Thank you very much for those rounds of applause. I can see them coming in. And thank you very much, Professor Tron, for this wonderful session. So Professor Tron has again taken us through modeling machine learning models with the use of Python. And again, we see some levels of data exploration using the latest DHS data, that is 2024 data. And then we see the distribution, and then going on into the classification using different manual model as well as a class balance model. Thank you very much, Prof, for this wonderful session. I wouldn't know if we have questions for Prof. Quick questions for Prof. Okay, I think we have some. Okay, let me take from the chat box before maybe those of us that have questions that might want to indicate and speak from here. So let me take this first question from the chat. So this first question reads, say, please, Prof, can you please mute? Thank you. So the first question here reads, please, Prof, could you demonstrate back propagation?
That's a very big question. And I mean, if you like, I can present the theory tomorrow. But typically, when you use machine learning, backpropagation is done for you. It's part of the model. I do have some slides that illustrate backpropagation I can show tomorrow. So I guess that's my best answer to that question.
All right, thank you very much, Prof. I think the person that asked that question, Prof, has just responded by saying that he could share with us some insights on backpropagation tomorrow. So hopefully you'll be here on the call tomorrow to listen while Prof give a bit talk on that. Thank you very much for that question. So another question here reads, say, please, can we see Prof slide on the exercise 5? I think this is a request. Can we see Prof slide on exercise 5.1? I want to screen much what he did, please.
Okay,
I don't
sure.
know.
Okay.
Oh, thank you very
just
much,
let me show it back.
All right.
Just a moment. I share again. Let's see. Okay. Let's see. Go back to my VS Code here. And you said 5.1? Sure.
Yes, 5.1.
Okay, so I don't know if the person has any specific question on this.
Yeah, Ejiro, I guess. Do you have any specific question on this?
Or maybe they just want to take a screenshot, and I'm not sure.
I want to screen. I think she just wants to take a screenshot from the message here.
Sure. Okay.
I believe you must have done that. Also, you can go to the notebook on Google Drive, the folder. You can always get all of those things that's been shared to us. All right, so I don't know. Is anybody having a question again? You can indicate with your hand raised via the emoji. I don't think I can see any indication. Okay, so the Prof, we have a question here again. So can you explain the difference between balanced and manual classifier?
So manual here, you can see manual here. Specified the class weights. Counteract, you especially weight the lower class. You can think of it this way. Suppose you have 90 children who survived and 10 who died. So instead of training on this data set with 100 instances, 90 plus 10, what you do is you take each child that died and you duplicate them 5 times. Okay. So instead of 10 instances of children that died, you have 50. Because each child that died is enabled to be 5 times in the data set. So you have a larger data set. Instead of 90 plus 10, you have 90 plus 50 because you've duplicated the children who died to balance the classes. Okay. So when we did manual balancing, we decided how many times the underrepresented class was going to be duplicated. We said each child who died is duplicated 5 times. Now, for the class balanced, then the computer chose automatically what the weight should be. The computer chose a different weight. Okay. In fact, the computer would have chosen a weight that is in inverse proportion to the frequency. So instead of 1 to 5, it would have been something like 1 to 10, because there were 10 times as many children who didn't die as children who died. In fact, we can compare this to, we can do this class weight from 1 to 5. Let me go ahead and change this one here. Let me do another one. Well, here, instead of doing this, I'll do 1 to 9. Okay. Let me save these results, and then we can compare what happens. All right, this is the manual classifier. And I'm going to save these results. Okay. And we'll go ahead and do this with the new class weighting. In this case, the weight of children who died is larger. So I would expect a better recall than this. I would expect a better recall. So let's see if we do get a better recall now. See, the recall is much better, 672. Okay. So the only difference between this one and class balanced is that the computer chose the weights automatically. Okay. This one is quite close to the one that we saw here. It's very, very close. 672 versus 661.
Okay. All right. So thank you very much, Prof, for that wonderful clarification. I guess the person that asked that question must have gotten a very good answer and also a demonstration backing up that clarification. Thank you very much, Prof, for that for this wonderful session. I think except if anyone is calling my attention, but I think that is all we have for now. And I want us to again appreciate Prof for this wonderful session. Thank you very much, Prof. So after now, we'll be going for a break. But what do we expect after our break session? We should be expecting again the R class. And I believe for those of us that have checked our general platform, you must have seen the R script sent to that platform. So if you've not seen that, we want to go to that platform to check and see the R script and also the time series script that they all have been sent to the platform. And those are the materials which we'll be using for the next sessions today. We'll be having 2 more sessions today. So right about now, we'll be going for our break. And when we come back in the next, in the next 30 minutes. So let's reconvene the next 30 minutes. We will reconvene by 1:26. Yeah, by